integrated circuits. The lesson objectives are: 1. Define the NOT gate in an integrated circuit or an IC chip. 2. Define an OR gate in an IC chip. 3. Define an AND gate in an IC chip. 4. Define an XOR gate in an IC chip. 5. Expressing or drawing technique of a logic network. 6. Expressing or deriving technique of a logic truth table. Next slide, I am going to show you again the different types of logic gates and how each symbol is representing each gate. In the next clips, I am only going to explain 4 different types of integrated circuits or logic gates. There are the NOT gate, the OR gate, the AND gate, and the XOR gate. The NOT gate. A NOT gate looks like a triangular shape, with a small dot circle at the tip. It has one input and one output. The Boolean expression here is a dash bar at the top of each input or output. The output is actually the inverse of the input value. Let's see how the gates are represented inside an integrated circuit. One integrated circuit has 7 pins to the left and 7 pins to the right. All these pins are numbered. Starts from pin 1 to pin 14. Pin 7 is for the ground wire. Pin 14 is for the power supply wire, probably of 5 to 12 voltage energy. Other pins here are directly used by the NOT gates found inside. Inside each integrated circuit, there are 6 of NOT gates. As an example, the first NOT gate, assumed to be gate A, has pin 1 as input and pin 2 as the output. Next, the second NOT gate, B, it has pin 3 as input and pin 4 as output. And so on. It is shown clearly in the diagram on the far left side of this slide. The organ gate. It has the shape of a nose cone, or a rocket ship head. It has 2 input and 1 output pins. The Boolean expression here is a plus symbol. Here is a presentation of the OR gate. The integrated circuit has 14 pins, where pin 7 is for the ground, and pin 14 is for the power supply. The rest of the pins are for the OR gates found inside. There are 4 OR gates found inside. As an example, pin 1 and pin 2 are inputs and pin 3 is an output. Pin 4 and pin 5 are the input pins, and 6 is the output pin. And so on. The diagram to the right is how the internal presentation of the OR gates looks like. The AND gate. It has the shape of a big letter D, or like a helmet. It has 2 input and 1 output pins. The Boolean expression here is a star symbol, or a dot, for a multiplication process. Here is the presentation of the AND gate. The integrated circuit has 14 pins, which are numbered from 1 to 14, where pin 7 is for the ground wire, and pin 14 is for the power supply wire. The rest of the pins are for the AND gates inside. There are 4 of AND gates found inside. As an example, pin 9 and pin 10 are the inputs, and pin 8 is an output. Pin 12 and pin 13 are for the inputs, and 11 is the output pin. And so on. The diagram to the right is how the internal presentation of the AND gate looks like. The XOR gate. And it can be called as exclusive OR gate. It has the shape of a nose cone, or like a rocket head. It has an extra line at the base, like a wing. It has 2 inputs and 1 output pins. The Boolean expression here is a disjunction symbol. and it looks like a plus symbol in a circle. The Boolean equation is represented as x plus y times with x dash plus y dash. Here is the presentation of the x, or gate. The integrated circuit has 14 pins, which are numbered from 1 to 14, where pin 7 is for the ground wire, and pin 14 is for the power supply wire. The rest of the pins are for the X, or gates, inside. This integrated circuit has 4 gates inside. As an example, pin 9 and pin 10 are the inputs, and pin 8 is an output. Pin 12 and pin 13 are for the inputs, and 11 is the output. And so on. The diagram, to the right, is how the internal presentation of the integrated circuit looks like.